Okay, good morning. I hope that you're able to hear me now. I think I have the microphone on, but I'm very, very sorry. This time I don't have the camera on, and that's simply because, oh, excellent. Thank you for letting me know that you can hear me. So thank you for joining me. Um, the reason why I don't have a camera on it is that it seems like there's a lot of us now using at this time the um, various web meeting tools, and as a result the bandwidth was kind of running out. So what I want to do with you guys is to make sure that you're able to see the screen rather than seeing me. So we'll focus our energy on seeing the screen, but I am here and it is still me. So hopefully next week we'll see face to face again. I have set up the recording, but I'm quite happy to pause that. If there's anything you want to ask outside the entire class. But I have a couple of announcements, if I may, that I'll make, and then we'll make a start and have a look if there's anything that I can help you with, if there's anything urgent. I think that some of those announcements might answer to the questions that you might have on your mind. And the first thing that you'll definitely see is that we're dealing with this after waves of the network outage that Maricopa system dealt with. So rather than being on a week 11 when we were supposed to talk about the urinary system, now we're on the week 12 and we're talking about urinary system. And what that means, I'll explain in a few moments' time. And the other thing that I wanted to mention from the last week is that I'm really, really sorry that we had to reschedule the morning session from 10 o'clock till noon. So I know that that was an inconvenience. That was unfortunately, again, with the to ensure that we have the internet access available for everyone. But there is a recording available, and I'm very, very flexible with the deadlines if there's something that I can help with that and that you want to still ask about. But just like I said, few little announcements that I wanted to make. So first of all, there's the kind of a plan for today. I know that we talked last week about the Maricopa Systems outage, and I'm not going to go into detail of it again. I'll just explain really briefly what does it mean for you, just in case if you didn't get a chance to see the last week's video. And I'll give an update about the exam and practical 2 and other assignments, and then we'll focus on this week's material. But like I mentioned last week, I believe it was 16th when the outages fully kicked in. And what happened was that there were some concerns that with the network, and we have a protocol in place. And the primary focus whenever something happens is that we want to ensure the safety and security protocols, make sure that no student data, no data from elsewhere is at risk. And for that reason, a decision was made that, okay, let's take a timeout and put everything down and build it up from there. So as far as I have heard, and there's been a lot of communication. There has been not a single point where anyone should have to worry about that their personal information has been compromised or anything like that. So it was more of a proactive safety step that was taken. And the Tuesday's update that I have there is Tuesday from last week, not from this week. So I simply stole these slides from last week's presentation. So all of the critical operating systems were restored about a week ago. So all the email, Google tools that we use quite widely at the Maricopa system, both employee and student portals and internet were running as before. And classes resumed last week's Monday. The big thing here to note is that both the college as well as, of course, I myself have made a commitment that by there's no way that the student grades should be affected because of this. And I know that there's a lot of questions and there's a lot of concerns that how will we make it through this, but this is not the first time we've faced with unexpected changes. We are just looking at the end of the global pandemic, and you made it through, we made it through, so we can definitely deal with 1 week of disruption as well, having learned from that. So what this all means is that the last day of the course was pushed back by a week. So that means that this course will continue 1 week longer than we were initially scheduled. And I realized that it might work for some and it might not work for others. And for that reason, although I will go through the material, assuming that we simply pushed forward all of the due dates and all of the materials so that you have 1 week more to work on every chapter, and we will go through the material as if it was delayed by 1 week. I realize that some students might have, for example, work commitments or travel arrangements that they had counted on the semester ending on a certain day, and now it's going to be 1 week longer. So for that reason, I am going to be very, very open to facilitate anyone who wants to submit work ahead of the time. So we'll make that possible. I have a few changes that I'm still implementing to make that available. So I'll provide full details of that through an announcement, but that is possible. And anyone who needs extensions more than that a week that we are now kind of running behind, I am super happy to facilitate those. What my goal is that you can get the best possible grade that you deserve. So there's no effect on your grades because of all these things that have taken place. So I hope that clarifies some of the concerns. Like I said, we'll proceed as if we were proceeding normally with just 1 week later than where we were planning to be. But it is really time for the college, and it's something that I would have done normally otherwise. But I especially want to highlight that I am so willing to work with students. We will find out ways that work for you with the due dates. We will find out ways that work with you with your other commitments for life. So not to worry about any of that. So I've received also a couple of questions about the exam and practical too. So last week I mentioned that I had them almost finished, and there was just one more thing that came up, and I'm just finalizing it hopefully today. So those grades should be released soon. But the grade that you see for your exam and lab practical 3 at the moment, they are by no means the final grades that you will be walking away. So you remember that the automated grading system was kind of super harsh. Any spelling errors, anything that wasn't typed exactly the way that the automated system expected was marked down, whereas it shouldn't have. And you remember that I always gave points for simply trying, or points for telling me something, or partial answers, or even answers that just sound roughly like the word that I was looking. So please, please, please do not worry. Your grade is likely going to go up. How much it's going to go up, that's the thing that I'm just finalizing. But both exam and practical 2 grades, they are not yet shared. So the grade that you see there is not the final grade. So have a breather, and I hope to have them opened, if not today, then tomorrow, but hopefully today, if possible at all. So you have your final points for those. On that note, like I said, there's been a lot of things that we've been tackling with the schedules being turned upside down, spring break being extended by week, semester being extended by week. As always, I'm very, very happy to reopen any assignments that you might feel that you kind of missed out on or extend any due dates. All you have to do is let me know and I will work on those with you. It is my recommendation that you try to get all of those points that you are entitled to, that you can get, because that way it's so much less that you have to get into exams. But really the key on these online courses is to work through the material and not miss weeks, because it's those little points that add up to a larger number of points. So as long as you get them done, you'll be super good. And I do give towards the end of the semester, the finals project is basically, I believe, almost a chance to bring up your grade by one letter grade. So there's a lot of opportunities of adjusting where you're standing with the grades. But I recommend getting those assignments in as much as you possibly can. And I think that covers all of the announcement parts that I had in terms of what's going on and where are we with our thing. So the next part that we're going to be looking at is going to be this week's material. But before we do that, I just wanted to open the floor in case there's any questions in terms of anything that I've probably failed to mention, or anything that has been going on, or anything in relation to the practical things. Like I said, my goal is to be as helpful and make sure that we find solutions that work for you. That's what I'm here for. And one last side note, if you do hear sounds or noises at the background of birds, I don't know, making noises, that is actually birds. So during the spring break, I did get a bunch of new baby chicks. And because they're so young, they're still here in the house with me, of course, in a cage, not running wild. But they are indoors so that they're strong enough when by the time they go outside. So that is probably the noises you hear on the background. And if we had enough bandwidth, I would definitely introduce you to them, but maybe next week. But if you have any questions, you can either shout out or you can write to the chat, and I will pause the recording if it's something you don't want to ask from the entire class. But if you don't have anything, then the next thing that I'm hoping for us to kind of draw our attention on is going to be all the stuff about this week's module. Really, the material that we covered last week was mainly about the respiratory system, in addition to all of those updates. And we jumped this week from respiratory system to look at the urinary system. And I think that urinary system makes sense to have as a chapter at this point. I do know that some other textbooks, some other schools place the order of these final chapters in a little bit different order, that urinary system would come later. But I do think that this is a good time to cover that chapter. But like I said, if you have any questions, this is a good time. I'm always here, always, even after the session, always reachable via message on the canvas. But just know that I do encourage, and I'm totally happy to post the recording. But if I don't see anything, I'm gonna move on to the this week's material and a couple of things that I wanted to mention about it. So again, we would be working as we have been working in the past weeks, that the weekly assignments would be due at the end of the week. So I think that that's going to be April 11th, or maybe April 11th is Monday. April 11th is Sunday. So due at the end of the week. So there's nothing new. They are completed through the publisher, through the Connect, so McGraw-Hill's portal. The thing that's new, and I think that we have dealt with this already once, but it's been a while since, so I'm kind of gonna cover that again. And if we haven't, it's gonna be covered now. The thing that's new is that the lab is gonna be a little different from what we've seen before. And the reason why this lab is different is that it's built in a little bit of a different format from what we've been doing labs traditionally at the Connect. The lab that we're going to be looking at or using is something that's known as Phil's lab. And what Phil's lab is kind of a temperamental about is that it uses Flash Player. And as I'm sure that many of you know, the Flash Player stopped being supported at the end of the last year. So I realized that the Phil's lab might not work for everyone. And if it does not work for you, I've got here instructions how you can try to make it work. And if it still doesn't work, I do have an alternative lab assignment that I can give to you. But I really, really, really encourage you that let's try first. And then if it doesn't work, then we'll tackle that. And in addition to these instructions that you see about the Phil's lab, the Phil's lab actually is this ADH lab stimulation. And if I remember correctly, for this semester, I actually moved it as the very first activity for this week. So if you're wondering why they're kind of in an unusual order, that's because I just wanted to make it easy to find and easy to access. So let's have a couple of things that make it a little bit of a more challenging lab to access. And if you have any issues, do remember I am here. I have had great success once I do screen sharing with students. All of a sudden, we're able to figure it out how it works. It's just there's a little tweaking that's involved. But the lab itself is easy and quite interesting. So like I said, these labs are Flash-based. And to get them run, the big thing is that you either need to install the Flash Player or you might need to enable it. And because the Flash Player is no longer supported, most browsers, internet browsers, automatically block it. And if you feel uncomfortable using the Flash Player, you don't have to. Like I said, I will give you an alternative assignment. But most web browsers, you have to activate the Flash Player. So if you don't have the Flash Player at all, you would see something like this image here where it says that you need an Adobe Flash Player and get the latest version, and then you click there and work through that. But that's not usually the challenge that students face. The more common challenge is that you need to activate. And it might be that it's actually in two different places where you need to activate the player. So if you look to the very end of this bar, address bar, that's at the top of the browser that you're using, where you would normally be typing the web address where you're going, which is normally something www. and whatever. At the end of that bar, you might see a symbol that looks like a lock with a red slash through it. Or it might be that there's no colors. There's a little bit of variation depending on what browser you're looking. But if you're seeing something like that, it's probably an indication that there is an Adobe Flash Player activity that has been blocked. Then you click on that symbol and select Allow Flash. And that should help with the first part of this challenge. The second challenge that you might see is that at the other end of this address bar, so on this end, you might again see a sign of a lock, or you might see an exclamation mark, some sort of a symbol that you wouldn't normally see. And there might even be a text that comes up when you hover over it that tells you that this is not a secure site. If you click on that, there will be a drop-down menu from where you choose allow. And it might be, like I said, that you need to do it for both of these places for the Flash players to start working. So for me, for example, when I go and try to do the Phil's lab, I do have to do the other end of the address bar and click the allow the Flash player. And then I need to go to this second end where I do see the exclamation mark and I see the text not secure. Once I click on there, there's multiple options of things that I can choose. And when I find the Flash and I click the drop down menu, I have to find the allow option from there. And after that, the Flash player works and these field labs work. So I would encourage you to try those two. If they don't work, then, like I said, I'm here available to work with you. And if that doesn't work, I will give you an alternative lab. But what you should end up seeing is a page that looks something like this. It's a table of index of the Phil's labs that are available for you. And I believe that the lab that we're looking for is lab number 42, labeled as ADH or anti-diuretic hormone lab. And I think it is the very last lab, but I might be wrong about that. So if you look on this list that I have here, it's on the right-hand column, the very last activity that's shown here. Either way, just look for the lab that matches with the name of whatever we have listed there. If you do get stuck, we do have the McGraw-Hill with the their IT tech support number. They can help, and of course, I can help. I don't want you to be stuck. I don't want that. The biggest thing is that I don't want you to spend too much time fighting against computer to complete the assignment. I want you to spend the time rather on completing the assignment. So that's the biggest part about the Phil's lab and what's challenging about it. And I do think that we've completed one before, but if this is new, if this is causing you trouble, I am here to help and try those instructions that I have added there on the Canvas shell for this week's module. They might be very helpful. Do we have any questions about the Phil's lab? Anything else? If you have, I'm here and we can pause the recording as well. If not, what I'd like to do is for us to shift our attention to look through the key points of the urinary system. And what you'll notice when we are going to talk about the urinary system today is that it is actually a little bit shorter of a chapter. What I do, like I always do, I highlight the important parts on these weekly sessions. And we will be actually spending most of our attention on one single part, which is the functional and structural key component of the urinary system, a structure called nephron. And we'll talk about that nephron quite a bit. And in fact, what we'll do, we'll end up drawing a nephron together and going through it that way. And then there's other parts of the urinary system that we'll cover, but we'll cover them a little bit in not rushing through, but we won't go into as much of a detail because there's not as much new detail for any of you, I think. So what I'm gonna do, I'm gonna jump out of this presentation, provided that it's me out, and I'm gonna open up the slides that I was wanting to use with you. So let's jump to a new screen. And bear with me. Up and running. And let's share that. So you should be able to see a screen where I have kind of a walkthrough of the urinary system with the subheading Introduction to the Kidneys and Nephron, or a kidney and nephron. And what we'll do, like I said, we'll cover all of the urinary system, but you'll notice very quickly that the main emphasis on everything that we'll be discussing is going to be this structure here, a structure called nephron. And that's something that I want us to spend the time on. I want us to feel very comfortable with, even though it doesn't mean that other structures wouldn't be important, but that's the most important structure for us to be familiar with at the end of this chapter. So without further ado, I think that we have seen a formula that looked like a little bit like this before, and I mentioned at that time that it was a great way of reviewing everything that happens in your body. Not necessarily everything, but most of the things. So what we saw that this formula connected very nicely our digestive system, and I think actually even our cardiovascular system, and our respiratory system and our urinary system. So we see that all of these systems are interlinked, and all of these systems are needed for us to do what your body does best and what your body does as its main function. So the very first formula that we see here at the very top is something that you can recall from the past, back in the day when you took the BIO181 or BIO156, a formula that explains basically what happens in cellular respiration. So what happens when you take energy from the food, so let's say sugars, for example, and you combine them with oxygen. And of course, we get the oxygen to your body from respiratory system, so through the lungs, breathing it in. And that's what we had a look last week. Well, if you combine sugars and oxygen in the body, around and within a structure known as mitochondria, what you are ending up producing is ATP, which was the energy currency in a cellular scale. So ATP is what we make, and that's just a form of chemical energy that you can use then wherever needed in the human body. Well, as a result of all of this, you are left with some waste products. And the waste products that we are left here with are going to be carbon dioxide and water molecules. So they are leftovers from this reaction where we change sugars and oxygen into ATP. Well, we need to find a way to get rid of the carbon dioxide and water. And that's where all of these other systems step in and help us. And we talked about how we use the cardiovascular system to transport carbonic acid. And so we change the carbon dioxide and water into carbonic acid. And once we get to close to the respiratory system, we can change the carbonic acid into bicarbonate. And bicarbonate can be just simply breathed out through your lungs. And we are left with extra hydrogen ions. And hydrogen ions are something that we usually get rid of through our urinary system. So really, I'm not expecting you to memorize this formula. I'm not expecting you to memorize the chemistry. I just simply want to show that we went from this point where we got sugars from food, we had our respiratory system taking part, we got energy out of that, and we needed to get rid of some leftover things, and we got rid of those through respiratory system and urinary system, and the urinary system is the topic that we'll focus today. What I want to show with this equation really is that all of these systems are interlinked, they work together, and we need all of them to be able to do all of the things that we want to do in the human body. But no need to memorize this, no need to memorize the names of different elements or the carbonic acid equation. Simply know that we do need all the systems, and today our focus is going to be, of course, on the urinary system. And how do we get rid of material, including these extra hydrogen ions that we are left with by using the urinary system? So that's simply to tie in all the chapters that we have looked at. And what I want to do here is just go through the four main different parts of the urinary system. And what should you know about the urinary system? What's important about it? So we'll spend the first part of this class or this review session on talking about the kidneys. And of course, we all have two kidneys. They're the major organ of the urinary system. And really, when I ask about the functions of that, I get various different answers. And we'll focus on what is the real function of the kidneys. Why do we need to have kidneys? And students often would tell me that it is the production of urine, that's why they have kidneys. And that is true. We do end up producing urine, and it is the structure called kidneys that do produce that urine. But it turns out that the urine is more of the product that's made as a result of another process that's important. And the other process that's important, why we actually want to do all this, is that we want to be filtering blood. And as we filter blood, we're able to regulate your blood pressure. So it is really the blood pressure regulation. Most blood pressure medications actually act on your kidneys. But of course, as a byproduct, we do end up producing the urine. But just remember that it is the filtering blood and regulating the blood pressure that really results in us producing the urine. So I would highlight, if I was asked what's the main function, this role of the blood pressure regulation for the kidneys. So that's what we'll look at first. And after that, we will shift our attention that we will talk a little bit about our ureters. There's two of those, one from each kidney, and the ureters run from a kidney to the urinary bladder. So they're simply a transport structure, a structure that helps moving stuff from the kidneys to the urinary bladder. Well, we'll talk about urinary bladder, which is not much more than just a temporary storage place for urine that has been produced until we're in a place and time where we can expel that urine. And when we are ready to expel that urine out of the body, it is urethra that we use to do that process. And as you saw, we only have one urinary bladder and only one urethra, whereas we had two kidneys and two ureters. So those are all the structures that we'll cover today. And like I said, we'll spend quite a bit of time on the kidney and especially on the structural and functional component of the kidneys, a structure called nephron. So what we see here is kind of a little introduction, many functions of the kidneys. So kidneys do a bunch of things. They, for example, play a key role in regulating the total water and solute concentration. They regulate the ions in the fluids. They help us with pH balance, regulating that, removing any waste, toxins, drugs. And we talked about the important role of the kidneys in blood pressure regulation. They also play a role in vitamin D activation, and if there needs to be glucogenesis made, they play a role on that as well. But really, the big thing to remember with the kidneys is that they filter the blood. And by filtering the blood, the kidneys are able to regulate the blood pressure. If the blood pressure is too high, let's get rid of some of the content of the fluids in the blood. And if it's too low, let's make sure that we don't remove too much anything from the blood. So kidneys are very responsive to these needs of the body in terms of whether we want to bring up the blood pressure or whether we want to bring it down. So blood pressure regulation through filtering of the blood is what kidneys do mostly. The other thing that I wanted to show here was to talk about the external appearance of the kidneys. Kidneys are kind of these reddish brown, a little bit like bean-shaped structures. And when we are looking at the kidneys, we'll notice few different parts of them that are kind of characteristic and worthwhile for us to note in terms of describing the kidneys. And let's start by having a look of those. So the first thing that we'll notice is this medial surface that's concaved. So facing to the middle of your body on both sides is this concaved medial surface of the kidney. And you'll notice that it's the same whether you're on the right or left side, it points to your midline of the body. On the lateral surface, so on the sides of your body, you find another curvature. But what's important to notice of this medial surface, concave surface, is that we've got actually blood vessels coming to the kidneys, we've got lymphatic vessels coming to the kidneys, and we've got various nerves coming to the kidneys. And they, of course, leave the kidneys as well. And what I'm showing here is the convex lateral surface that I mentioned earlier on. So the bigger curvature is on the side of your body, facing to the sides of your body on the convex side of the kidney. So there's a lot going on, a lot of stuff being brought into the kidney through the blood vessels, through nerves, and through lymphatic vessels. So there has to be a lot happening with the kidneys. And that's what we'll be focusing on today. And that's why kidneys are such a delicately designed and smart structure that every time that I teach about the kidneys, I'm left wondering that how clever has nature been of engineering this structure. And what happens is that we actually end up noticing that whereas many other organs and structures in the body tend to get weaker or less functional over your lifetime, kidneys seem to work pretty good because they're over-engineered. There's so much ways of kidneys accomplishing their goal and their role that rarely do they cause us issues as the life cycle is continued to the old age. One final thing that I wanted to mention about the kidneys is that often if we look at the kidneys in terms of from the external part of them, we notice that they have this very smooth surface. And this is because they are enclosed in a fibrous capsule. And this fibrous capsule is renal capsule. And the kidneys are inside this renal capsule. So they appear of this shiny, smooth surface of a kind of like a large bean. couple of other things that I want to mention about the kidneys. They are something that we describe as a retroperitoneal structure. And you might remember we've used this word before. So peritoneum was the structure that lined the abdominal cavity. And since it's retroperitoneal, it's behind that. So what I find with most of my students when I discuss that most students are very surprised how far back towards your back of your body the kidneys are. So they're not too far from the surface of your body from the backside. And that's why I don't know if you really need this in Arizona, but I've lived in quite a few colder climates. And in those climates, electric blankets, these heated blankets, are very common. And what I end up finding is that a lot of people prefer to sleep on their back. If you sleep on your back on an electric blanket, there is a risk that you will actually overheat your kidneys a little too much. So don't blast the electric blanket on the maximum temperature and then go and fall with it on the back of your body, because the kidneys are so close to the surface of the back. But it's not something that's a big problem, but something to bear in mind. So kidneys are anchored to the peritoneum and abdominal wall by fascia. And I think that if you're thinking of their size, an adult-sized kidney, they're about 12 centimeters long, 6 centimeters wide, and about 3 centimeters thick. And there's a lot of adipose tissue or capsule of adipose tissue that surrounds the kidneys. The function of that fat layer there is really to just give protection. And the final thing that we'll notice here, of course, is, like we've seen in our previous chapters, that there is the adrenal gland on top of the kidneys. And we talked about the adrenal gland quite a bit at the very beginning of this semester when we looked at the endocrine system. So let's move on and have a look. One more important thing that I want to highlight. So we have two kidneys. We have kidney on both sides, on the left and right side. One important thing to notice is that if we compare the left and right side for the kidneys, it turns out that the left side kidney is located higher up than the right side kidney. You might wonder, why would this make sense? Because usually human body aims to be very symmetrical, but there is a distinct difference between the height of the kidneys. Well, this is because there is the liver located at this area, just above the kidneys, so just superior to the kidneys. And you might remember that liver was larger on the right-hand side and only the very tip of it extended to the left-hand side. So because liver takes this large space here, that's the reason why the right kidney is lower. There's simply no space for the right kidney to climb to the same or be located at the same height as the left kidney. So something to just bear in mind, that we do end up finding that the left kidney is higher, right kidney is lower. And I think that that would be something that would be very nice to ask in an exam as a simple question. There can be, of course, various different kinds of clinical issues that we might end up finding. There might be one or both kidneys dropping to a wrong location. Or what I think is more exciting and more interesting is when we have backup of urine. And that would be because there would be an obstruction somewhere within the urethra or somewhere within the system, really. I think it could be ureters, it could be at the bladder or urethra, but we are not able to get rid of the urine from the body. We're not able to expel that. And as that reason, the urine keeps building up and up and up, and eventually that can lead into a severe kidney damage because of it building up and we're not getting rid of it. So backing up of the urine could become a problem. So really the reason why we cover all of these basic anatomy and physiology is so that you have an understanding when something abnormal happens, and when you continue in your studies and you start talking about abnormal stuff, you know what is normal and what should be happening. So I'm not expecting you to be experts of the pathologies. I'm just wanting to show that things can happen, and it's important to know the basics so we can understand what's normal. When we look at the kidneys, we can also look at the internal structures of the kidneys. And there's a lot going on in there. We end up finding both cortex and medulla. The cortex that I'm highlighting here is superficial part, just like we had a cortex of the brain. So the outermost layer, outermost part. And then we have these parts that are deeper to the kidneys within the medulla, and there we find various different structures, such as these pyramid-shaped, these cone-shaped structures known as renal pyramids. And of course, we then have the renal pelvis, which is this tube that starts as a kind of a funnel and then turns into a ureter. We also have something that are known as the as our renal columns separating the different renal pyramids. So I've highlighted that on a green color there. So all of these might seem like, well, why does it matter? But once you actually get to work on a kidney and get to really dissect that, it starts making sense. And since we are in an online format and we're unable to dissect the kidney ourselves, I'll try to find a video. I think I have quite a few where I've recorded dissection of a kidney with students of mine, and I'll upload it on this learning mode. But here, like just to summarize, recap what we just discussed, you saw the cortex on this purple color. We see the medulla, and from the medulla, these renal pyramids that are really like these cone-shaped, triangle-shaped structures of darker tissue within the kidney. We saw these renal columns that were running in between the renal pyramids, kind of the paler structure of the cortex expanding inwards to the kidney. And then we had finally the renal pelvis and the funnel-shaped tube that comes out of there and then turns into the ureter. So there's a lot going on in the kidney in terms of the surface and internal anatomy. But what we're going to be moving our attention to is the physiology. And all of the physiology really depends on or relies on one structure. Hold on, I'm just gonna jump out of here. I forgot to delete that video. Normally I'm pretty good about deleting the lecture videos, so let's move back there. So the structure that we're gonna be, oh, still not. The structure that we're gonna be, this should work. The structure that we're gonna be looking at is gonna be nephron. Nephron is really where everything that the kidneys do happens. And this is what a nephron looks like. And there's going to be many parts in a nephron that we will need to learn to understand the anatomy, but also the physiology of it. But rather than me throwing you a slide where I have all of those labeled and then just talking over them, I thought that what would be probably the best thing is that we draw it out together. So if you have note-taking tools, that's great. If you don't worry. I do try to upload the drawings or provide the drawings at the end to the Canvas course as well. But I find that at least I and many other students learn better when you follow along when we're drawing it. So what we're going to do, we're going to draw out a nephron. And let me just get my tools up. So we're going to draw that together. And what's important to know about nephron is that there's about 0.8 to 1.5 million nephrons in single kidney. So there's a lot of those, and for that reason, they're really the business end. The business end of what happens and how the urinary system works. So we're going to be focusing on the nephrons for the biggest part of this remaining time together today. And like I said, it is the functional and structural unit of the kidneys, these nephrons. So it's both both anatomically and physiologically, the key part, the vital part of what happens in the kidneys. So that's why we're spending so much time on. So let's start. And where we're going to start is that we're going to have a blood vessel, that's going to come in to a nephron. And we're going to have another blood vessel that comes out of the nephron. And I'm leaving there a gap for this blood vessel that leaves the kidney because I'm going to do a little bit more with that blood vessel. But at this point, you just simply need to know that there's one blood vessel that comes in and one blood vessel that leaves. And we're going to name these blood vessels. So we're going to have an afferent arteriole. So you remember that the arterioles were the smallest of the blood vessels before the capillaries. And then we're going to have an efferent arteriole. And what we remember of these is that the afferent comes in and efferent leaves out. So those are the two blood vessels coming in and leaving the nephron. And if you do prefer, some students find that using colors helps them. So you can, of course, color them. And really, the color that you color them in does not matter. I'm just using simply red color to make it more obvious as a blood vessel. but whatever works for you, whatever you find that helps you to remember that those are the blood vessels coming in. The next thing that we'll notice, of course, at the end of the arteriole, we would have our capillaries. So we have this network of capillaries that's formed in here. And because they're very, very small blood vessels, I'm drawing a lot of these gaps in there. So they're forming this kind of a network of very, very, very thin vessels before leaving the nephron. And these capillaries are known as a glomerulus. So that's the network of capillaries. And again, if you do prefer to use colors on your notes, this would be the network of thin, 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 smallest blood vessels. Now we have all the blood circulation coming in and leaving, and what happens between those there. What we're going to do next is that I want to talk a little bit about the actual nephron, which is the structure that works around this. So this capillary that we see here is actually surrounded by the first part of the nephron, which is going to be our structure of interest to start with. And it's surrounded almost like if it was closed into this kind of a ball-like structure. We're, of course, drawing a cross-section of it. So it's going to be a little bit kind of a like a diagrammatic representation. It would surround the entire glomerulus. In this case, I'm just showing half of it since we're seeing how it wraps around this capillary set there. And this one is known as a Bowman's capsule or glomerular capsule. So let's add that there. So this capsule surrounds the glomerulus. And again, for the sake of the fact that I prefer to think things by using colors to emphasize important structures, I'm going to use yellow color for the nephron, and starting with this. Ooh, that jumped further than I wanted. Starting with this glomerular capsule. So let's see if I can draw it again a little bit better. So like you saw, the glomerular capsule or Bowman's capsule, all that it does in terms of the anatomy is that it surrounds this capillary network. In terms of physiology, it does a lot more, but we'll talk about the physiology in a few moments' time. Now, we're ready to move on to have a look at the next part. So from the glomerular capsule, we've got a tube that comes out. And this tube is, if you wish to describe it, kind of a same thickness as what we saw in the glomerular capsule's thickness. And it wiggles around doing its job and then ends up at the end. And this tube-like structure that comes out of there is called convoluted tubule. And I can tell that there's going to be two convoluted tubules in this structure. And because we need to be able to tell these two convoluted tubules apart, we describe them in terms of how close they are to the glomerular capsule. So this one would be proximal convoluted tubule. And that's because it is closer to the glomerular capsule than the second convoluted tubule that we'll see a little later. So again, I'm going to color in our proximal convoluted tubule here because of making it easier, at least for me, to notice where it is running than just a bunch of dark lines. But again, whatever is your learning style, if you prefer writing full sentences from drawing, that works just as fine. But that's our proximal convoluted tubule. Well, after the proximal convoluted tubule finishes, there comes a thinner tube that continues from there. And this thinner tube does a loop going downwards and then coming back up. And it is continuous with this previous structure that we saw, the proximal convoluted tubule, but it is characterized by much thinner appearance. And this one is going to be known as our nephron loop. There is another term that you might sometimes see being used about it, and this term would be loop of Henle. Ooh, I didn't mean to change the color there. Let me just remove that. So this nephron loop or loop of Henle is this thinner part of the loop that we see right after the proximal convoluted tubule. And again, I'm going to color it in here just to make it easier to tell it apart from the other structures that we have seen and will see. So that's our nephron loop, loop of Henle. Well, you might not be too surprised that the next structure coming out from there is going to be another convoluted tubule, this time, of course, to describe its location, it's going to be distal convoluted tubule because it's further distance away from the glomerular capsule or Bowman's capsule, depending on which term you prefer to use. But what we notice is that a similar thicker part of the tube of the nephron, but this time further distance away. So let's label that as well. And like I said, it's going to be further distance away from our glomerular capsule, so it's going to be distal convoluted tubule. And again, I'm just going to color that quickly in so that it's easier to tell it apart. So we have only one more structure that we need to add to the actual nephron. There's something else that I want to add as a supporting structure, but the last part that nephron actually empties to. So nephron carries fluids inside it, and all of these fluids then empty to this larger tube that collects contents from many different nephrons. And this larger tube is going to be known as a collecting duct. So let's finish off that and label it here. So collecting duct collects whatever comes out of the nephron, and it collects that out from multiple different nephrons. So let's add that here. That's our collecting duct. So now we've drawn all of the key parts of a nephron. But there's one more structure that I want to add to there. And you might have noticed that I didn't finish drawing the blood vessel coming in and leaving. That's because this blood vessel does something rather clever before it leaves. So let's complete that part of this diagram. So I'm going to draw that blood vessel going down and traveling, following the nephron loop very close to it. And then leaving the nephron. But what's important to notice is that there's this blood vessel that travels right next to the proximal convoluted tubule, the nephron loop, or the loop of Henle, whichever term you prefer to use, and distal convoluted tubule. So this part of the blood vessel is something that we're just adding as the very last thing to our diagram of what's happening in a nephron. Oh, I didn't want to draw that long line. Sometimes my screen is a little too sensitive. So I'm just gonna fix that. Let's add that there. And now it might start making sense why I used colors, because there's going to be all these lines next to each other. So at least for me, it helps to be able to tell them apart, that what line refers to what. So what I'm going to do, I'm going to color in this blood vessel that follows the nephron, and like I said, the proximal convoluted tubule, the nephron loop, and distal convoluted tubule. So let's add those. So you might wonder, why would this blood vessel matter where it runs? Well, when we start looking at the function, the physiology of a nephron, it will become very obvious. So you'll notice that there is blood vessel running real close to all parts of the nephron. And the fact that it runs real close there is going to be important for what we'll be having a look of next. So that's our blood vessel, and that's all the parts of a nephron that you need to know. You might think that, oh, that wasn't that much. I hope it doesn't feel like it was that much. Initially, if I just show this diagram, students seem to be like, oh my God, that's a lot. But I really, really do hope that you'll end up thinking that, oh, it wasn't that bad. I can handle those parts. So the small blood vessel that we see running around the nephron is going to be a capillary, but so as very, very easily permeable vessel that we see there. So let's review the nephron once more by looking through a diagram that I drew before, but it should have all of these same parts that we just drew together. So let's start here. We have afferent arteriole and efferent arteriole. You don't need to use different colors for them. So afferent was coming in, efferent leaving. Then we have the glomerulus, which was this network of capillaries, still part of the blood vessels. And we had, of course, our Bowman's capsule or glomerular capsule that surrounded this network of capillaries. And after that, this glomerular capsule, out of there, we had a tube running out. And don't worry about that green arrow. What I just want to show at this point that something moves from glomerulus into the glomerular capsule. And that stage, we'll talk more about that in a second, but that's known as filtration. So you don't need to write that on your diagram just yet. We'll add that later on. But what you'll notice that after that, we have our proximal convoluted tubule. So proximal convoluted tubule came out of the glomerular capsule. And because it was the part that was more close to the glomerular capsule, it's going to be the proximal convoluted tubule. There will be another convoluted tubule that we'll see in a few moments' time. Then we had the nephron loop, which was this thinner loop that we saw, sometimes also known as loop of Henle, after the person who first discovered it. After the loop of Henle, again, this arrow you don't have to worry about, but you can just make a mental note that something leaves the nephron back to the blood vessel at the loop of Henle, and something comes back from the blood vessel to the loop of Henle, back to the nephron at this. And then we have our distal convoluted tubule. And of course, in this case, it's going to be distal because it's the convoluted tubule that's located further away from the glomerular capsule. And the very last part that I wanted to highlight here was the collecting duct. The duct that collected the secretions from multiple nephrons and collects all of them together. And again, there's going to be something that leaves the nephron, which is the final product made by the nephron. So this is a diagram that shows everything that we just drew together. So there's a lot going on, but really it's not that complex once you draw it yourself. And at this point, we don't worry about those big, colorful arrows. And what we're going to do now, we're going to jump out. We'll keep this. And we're going to jump and go back to our diagram that we drew here earlier on. And just because I want to make it so that we have our initial diagram, I'm going to draw on top of the diagram a few more things. If you have no space on your notes, you can just do various different stars and write it on the different place or whatever works for you. I'm just simply going to use a different colored pen. So let's have a look at the physiology of the nephron. So we remember one of the first things that was going on here was that we had material leaving the glomerulus, this capillary network, and moving from there into this glomerular capsule, or what we also knew as Bowman's capsule. So we had some liquids being taken out of the blood. So blood was getting filtered. And whatever was taken out of the blood, liquids and other material with that liquid, entered into the glomerular capsule. This stage, this process is known as filtration. So I'm going to add it here. Just let's do a coding of different events. So during filtration, we take something away from the blood, and whatever is being taken away from the blood enters to the glomerular capsule, or Bowman's capsule as we called it as well. So that's the first step of the actual physiology of the nephron. Well, then we got to our proximal convoluted tubule and our nephron loop, or loop of Henle. And what we saw happening here was that some of the material was taken away from the nephron and put back into the blood vessel. So there was a movement away from the nephron back to the blood vessel, this thin capillary that goes around the nephron. So I'm drawing an arrow showing the movement of materials this way. And this movement of materials is going to be known as reabsorption, because material is being taken back to the blood. So material is being absorbed back to the blood flow. So that's our next arrow, the blue arrow, from the proximal convoluted tubule and nephron loop back to the blood flow, back to the circulatory system. Well, that's not all. Then we get to the distal convoluted tubule and more the distal part of the nephron loop. And we had a reverse process taking part there. So material was being taken from this capillary that ran next to the nephron and being put back into the nephron. So material gets taken and put back into the nephron. Seems like we do something and then we have a chance to do something opposite to that. But that's part of that, what I mentioned, over-engineering of the urinary system, that there's many stages to fix if something doesn't get done exactly correctly. And this stage is known as secretion. So we secrete material from the capillary back to the nephron. And now we get to the very last event that happens here. And that very last event is going to be the material that leaves the nephron and goes to the collecting duct. So which is really the end product, the resulting product. And this would be the urine that leaves the nephron. So this would be the pee that gets produced. So after all of these steps, whatever is left is going to be our urine. That's going to be our excretion. So those 4 steps are all of the steps that happens during the physiology of the nephron. And that's as much as you need to know about the movements of the material. But what you'll notice is that first we do one kind of a movement, and there's a chance to do opposite movement. And the resulting thing that gets produced, of course, is going to be our urine. So this is really how urine is made on a level of a single nephron. And remember that there were lots and lots and lots of nephrons in a single kidney. So that's our physiology. And what I'm going to do again, I'm going to jump back to the slides to highlight these rather than our own diagram. Here we see the functional events of a nephron. What would happen? So first, filtration was the movement of material from our glomerulus, from the capillary network, to the glomerular capsule or Bowman's capsule. Then we had reabsorption. Reabsorption was the movement of materials from the proximal convoluted tubule and nephron loops, proximal part, back to the blood flow, to that small capillary next to it. Then we had secretion, which was movement of materials from the small capillary vessel next to the nephron, back to the nephron loops, distal end and distal convoluted tubule. And the very last step, the excretion, was materials leaving the nephron through the distal convoluted tubule and being collected to the collecting duct, which collected this material from multiple nephrons together. And all of these events are there to have this over-engineered appearance or over-engineered nature of the nephron. So we have multiple chances to adjust what leaves, what goes back to the blood. And what we actually can do with all of this information in clinical practice is that we can actually measure something that's known as glomerular filtration rate, often abbreviated in medical notes as GFR. And GFR tells us that how much blood passes through a glomeruli in each minute. So in other words, it tells us how well your kidneys are working. And this would be important in many circumstances. For example, if we're giving a patient some sort of a medication or some sort of a contrast agent that needs to be taken away from their body eventually. Well, we can't give that if the kidneys don't work well. So we want to know before we give this, what is the patient's glomerular filtration rate? And if the GFR is too low, we're not going to be using that. Well, this brings us back to talk about something that we've seen before, our good old friend ADH, antidiuretic hormone. And you might remember that we talked about antidiuretic hormone when we were talking about the endocrine system. And the big thing here was that let's remind ourselves, what does the name tell us? What does ADH do? Well, it's something that helps us to do a thing against urination. So we are producing less urine. And if you look at this diagram, ADH acts on the distal convoluted tubule. So what ADH does, it changes the wall of the distal convoluted tubule, which we see here, and makes it very permeable, so materials are able to leave the nephron and go back to the circulation. Well, if materials are leaving the nephron and going back to the circulation, we're going to produce less pee, less urine. So we're going to be able to do less urination. It's anti-urination hormone, antidiuretic hormone. So antidiuretic hormone, the important part about that is to remember that it acts on the distal convoluted tubule, on the last part of the nephron. And I think that that would be a very good exam question as well. And that really completes our review of the kidneys and nephrons. And I know that we're running a little over our scheduled time. So the very last thing that we're going to do, we're going to have a look very quickly of the ureter, bladder, and urethra. Before we do that, though, I want to say a couple of words about urine. So urine is mainly water, about 95%, and only about 5% of the composition of the urine is made by the solutes. And there's many different kinds of things. Most of those are nitrogenous waste, so urea, uric acid, and creatine. So things that we want to remove from the body, we don't want to keep them in the body. They would become an issue if you have too much urea, uric acid, or creatine, for example. Then there is a bunch of other solutes that we end up seeing also in the urine, but they're in lesser amounts. One thing that you should never see in urine, however, is blood. You should never have any blood in the urine. No blood in the urine. If we see blood in the urine, that would be indicative that we have a serious problem that we want to have a look of and figure out what's happening there. So we don't want to see blood. And another thing that we don't want to see especially is the white blood cells, because white blood cells, as you remember, were a sign of some kind of an infection that was taking place. So that would be a concern for us as well. So remember, never blood in the urine, even though there could be all sorts of other things, but if we find blood, that's a problem. So let's have a look of our ureters as the first part that we're going to talk about. So ureters are about 25 centimeters long tube that's made of smooth muscle. And the fact that it's made of smooth muscle is going to be very important for us. You remember, smooth muscle allowed us to generate this movement of material in a tube. This movement was known as peristalsis. We'll talk much more about that when we talk about digestive system. But basically what this smooth muscle wall lining of the ureters allows us to do is that it moves the urine from the kidneys to the urinary bladder, even against gravity. So you can be standing on your head and urine still moves from the kidneys to the urinary bladder. Same goes for astronauts who are in space. Their urine would be moving from right part, from the kidneys to the next part, to the urinary bladder. So smooth muscle makes sure that the movement of the urine produced is going to where we want it to go. And really, I think that that's as much as I really want to say about the ureters. Two of them, basically just tubes with muscle wall. Well, then the ureters enter to the bladder, to the urinary bladder at the base of the bladder. So at the bottom of the, not at the top as you might initially think. It's actually much more important that they come in here at the bottom. They kind of wrap around the urinary bladder and open up here at the bottom. So what we're going to see in this diagram is looking at the bottom of a urinary bladder. There's the two openings of our ureters at the posterior part of the base of the urinary bladder. And then there's one opening of the urethra. And we'll talk about the urethra in a few moments' time as the next structure. So that's this structure that empties the urinary bladder to the outside world. So because there's three openings, that sometimes is called as a combination of these structures forming this triangular area. And the name of this area is trigone. And trigone might be useful if you're, for example, trying to describe a location within the urinary bladder or trying to define which of those holes are for ureters, which of those holes is for urethra. The next structure that I want to talk about really is going to be, or next is going to be the urethra. So urethra is the structure that drains the contents of the urinary bladder to the outside world. And again, it's a muscular tube, and there's many sphincters that control at what flows from where to where. And one thing that we notice is that the urethra is much longer in males, about 17 to 19.5 centimeters in long, than it is in females, where it's only about 4 centimeters long. You remember that in males, the urinary system and reproductive system are actually going to be shared. So we have same material, both urine and the sperm passing through the urethra in males, whereas in females, the reproductive system and urinary system are completely separate. But it is this shorter distance of the urethra in females that makes females much more likely to develop UTI, so urinary tract infections. So the journey for the bacteria to climb up from the outside of the world, up the urethra, into the female urinary bladder is much shorter than the journey what it would be for the males to climb up the male urethra and reach the urinary bladder. So that's why females are more likely to develop UTIs. So I think that that's quite enough about the urethra. One last thing that I want to talk about is this term, micturition. Micturition is a more of a medical, more of a proper term to use when we talk about urination. So rather than saying that I need to go and use bathroom to go and have a pee, you can be very elegant nowadays and use proper medical language and say that I need to go and practice some micturition. So expelling urine is known as micturition. The last thing that I normally cover with my students, I discuss about things like bladder stones. I discuss about lifespan changes, but like I said, there's really not much going on in urinary system. Urinary system is over engineered. Even though things might slow down, there might be some scarring, cell death, loss of glomerulus, flow of blood slowing down, less holding capacity. At large, urinary system works really well even when we get old. So that's everything that I wanted to say about the urinary system. And we're going to jump back and we're going to go and look at the last things for the this week's chapter. So let's get the slides changed. So bear with me. And my computer is thinking a little bit. Seems like there's a lot going on. So let's hold on a second. And we're going to pull up our earlier presentation that we were looking. And let me share it with you. So you should be seeing the PowerPoint that I'm sharing with you again. So we have gone through the main points of the urinary system at this point. The last thing for us to discuss very briefly is then about the fact that, like I said, I'm always happy to facilitate if you want to retake any missing assignments, or if you didn't get quite as good of a score as you were hoping for some of the assignments. Just think about before you retake it. Is there something you can do differently? Did you run out of time? Is there something that you want to study before? Do you want to have your notes next to you? I always encourage checking out the feedback from the previous activity. If the system gave you that these are the questions you got right, these were the ones that you got wrong, before taking it again. But the big thing is that message me with specific details of what activity you want me to either reopen or reset for you. Usually I'm quickest to answer through the messages from Canvas, but I do also answer, of course, to the messages through email. And I always want to remind you that we, of course, have the Cranium Cafe, which is our electronic version of tutoring services. So you can pick the tutor you like working with. And I am also available for you, not for other classes, but for you just by appointment. So if you want to have a chat with me, if you want me to re-explain something, you just send me a message and I will always be super happy to help you out with any questions that you may have. And at this point, I guess it's a good time for me to ask, is there anything that you have questions, whether it's about the lecture material from this week's chapter, or whether it's about the Phil's lab, for example, or if there's anything else that you have questions for me or that I can help you with. Please do not hesitate. I'm here to help you. I really want to assist with anything. I know that it's been, again, I thought that we were over those challenging semesters, but it's been a weird semester. Can I help you with anything?
I think I'm fine, thank you. But I also have a question regarding the assignment we did miss. So, I think I have a lot. I don't know.
Let's have a look. What I'm going to do, if you don't mind, I'm going to pause the recording just so that we can look at your grades.
Yes.
And we're back recording. So now that we have finished whatever I had to look with individual students, I just want to remind you that if you ever have any questions, whether it's about the chapter material or whether it's about technical aspects, for example, of how to complete an assignment on a Phil's lab, I am here to help you. That's what I'm here for. I want all of you to succeed. That's what I want to see. I want you all to get the great grades that you deserve. I did just remind the student that I was talking with that to remember that at the end of the course, on the finals week, I also offer an activity as part of which you can actually earn a lot of points. I think it's almost as much as full exam, or it's a lot of points that can move your grade up significantly as an extra credit activity. So please don't worry. At this point, the big thing is to stay on top of the workload. If you've forgotten something, you haven't gotten quite the points that you wanted, we can go back, get those fixed. But this should be low stress course for you. This should be something that you can do without being too panicky. And on that note, that completes everything that I had planned for today that I wanted to talk with you. As always, I can be reached through the Canvas messages. I can be reached through email. Probably the Canvas messages is the quickest. I know I have a couple of messages there to answer, but I think that actually most of the answers to those questions came of this week's session. So thank you for joining me on this recording, and I hope you have a very good rest of the week. And I really do thank you all for sticking through these weird times of a global pandemic and then all of this network outage that we have been dealing with as a college. I am very, very grateful to have all of you as part of this class. And I really appreciate all of the excellent work that each and every one of you has been putting on this class. And hopefully next week I get to show you a couple of my young baby chicks that are living in the house with me until they're older. So hopefully next week we'll get to have a look of those. Have a good week. Thank you. Bye.